Good day, beautiful students, grade 12 learners in particular. Today I've got a trial paper from Limpopo province that I want us to discuss, at least in the literal sense. We'll pay a specific focus to question 3 that is heavily connected to grade 11 concept, but sometimes makes students' life to be cold in the exam room. But they are equally the questions you should be counting in the bedroom. And please don't forget to subscribe to my channel for more mathematics content and Mzansi content. Let's see what we have here in question 3. They are saying that 3.1, the points D, E, and F are collinear. So the most important thing here is collinear. What are we talking about? We're talking about the points that lie on the same line, which is D, E, F in this particular argument. They lie on the same line or they have the same gradient as the second point. So now they are saying to us 3.1.1, calculate the value of t. So they want this value here. Let's see how far we can calculate the value of t just right there. Now I'm gonna go to 3.1. I'm gonna write 3.1 just right here. We are given the point D. The point D is -3 and 0, and the point E is 3 and 5. We are also given the point F. So the point F here is t plus 2 and 5 over 2, which is primarily 2,5. So these are points that lie on the same line. I'm just going to write that line for you. So this is a point D here, this is a point E, and this is a point F. It's just somewhere there. In fact, let me just do this and reduce the size here and put it just right here. I've got my point. Now they are saying to us, remember that this is D and this is our E and this is our F. So these points, they lie on the same line, right? And they have the same gradient, you know. So now we want to go to 3.1.1 where they are saying to us we must calculate the value of t. And please guys, check the marks there. This is 4 marks, so do not skip any step. It's worth the struggle. Now we want to find the value of t. The best approach will be to say the gradient of DE is the same as the gradient of EF. Or you can say that the gradient of DE is the same as the gradient of DF. That means collinear. So we are going to say that the gradient of DE is the same as the gradient of EF. This is also the same as the gradient of DF. DF, just right there. And then this will be the collinear for that reason. This is a collinear. Let me write it here for you guys, that this is a collinear. Just right there. It's collinear points. So now you can check which one do you want to work with. So I'll advise you to work with the points that have zeros, or you can just work with anyhow. Now let me find the gradient of DE first. So I'm just going to find the gradient of DE and this gradient of DF, because this is 0 just right here, and it will make my life easy. So therefore, I'm going to say the gradient of DE will be equals to the gradient of DF. I'm going to be working with these two equations. I can work with this one and that one. You will still get the same answer anyway. So let's see. The gradient of DE is primarily 5 minus 0 divided by 3 minus 3, so it's more like plus 3, that is equals to the gradient of DF. So F there, the y1, y2 minus y1, which is 5 over 2, minus the y at D, which is 0, divided by t plus 2 there, minus the y at D, the x at D, which is minus 3. So it's minus 3, which is positive 3, just right there. So we are going to say to ourselves, therefore, this is 5 over, this is 6. It's very clear there. that is going to be equals to, if you look at this situation here, you'll see that it's going to be 5 over 2, or you can say it's 2.5, it's the same thing, over t. 2 plus 3, it's more like 5, so you write plus 5 there. And then now, what you can do is to cross multiply, and we're going to get 5 into t plus 5, just right there. That is going to be 2,5 into 6. Let's see what we get here. We get 5t plus 25 is equals to 2.5 times 6. It's more like 15, I would like to believe. Please do that on your calculator. It's 2.5 or 5 over 2 times 6, you get 15. Just right here, I was confirming it in my question, that is 15. Now we're going to have 5t is equals to 15 minus 25, it's more like minus 10. So therefore this leaves us with our t. So our t we divide throughout by 5, and that is negative 2. So I hope you grade 12 learners, you got negative 2 when you were doing this particular question. So the answer is negative 2, the value of t. This is how you would go about the first question. I'm going to do everything in this question, so just pay attention and watch up until the end. Now, they say to us, hence, that means you can use the previous equation. Hence, determine the equation of the line passing through DEF. So we want to find that equation, but in this particular format. So this is a very easy stuff, I would like to believe. So we want to find the equation of the line, this particular equation. We want to find that equation. So because we know that the gradient of this line is the same throughout, that means if this gradient is 5 over 6, it means this gradient as well is 5 over 6, even this one as well. So we are going to say to ourselves now that, let me go to this one, that is 3.1.2. So we want to find the equation of the line passing through those 3 points. So we're going to have y equals to mx plus c, where c is the gradient of these 3 points, and that is 5 over 6. So therefore, I'm going to get y equals to 5 over 6x plus c. Remember, to get this c, to get the value of c, you take any points between D, E, and F, and you substitute into this particular equation, because that's where the points passes through the line. So they are going to give you the value of c. So I'm going to say at point, which point you want to use here? Let's use D, on the basis that there is 0 there. So it makes my life easy when a value is 0. So I'm going to say at point D, that is negative 3 and 0. I'm going to substitute that point in that particular line. So let's see what we get. We get 0 here, that is equals to 5 over 6 multiplied by x. Our x is minus 3 into the particular equation, and plus c. So therefore, you've got 0 is equals to, if you multiply these two, you get a negative 5 over 2, I would like to believe, plus c. So therefore, our c is going to be 5 over 2, if you transpose that to the left side of the equation. Now, we have our equation, which is y equals to 5 over 6x plus c, but our c is 5 over 2. But remember that they were very specific about how you should leave your answer. They said your answer must be in this fashion. That is ax plus by and then plus c. All right. So what we're going to do is, and by the way, that must be equal to 0. That means all the time must be in one side. Now, check. Now, I'm going to clear fractions to say, let me multiply throughout by 6. That is going to be 6y is equals to 5x. If you multiply this by 6, you are going to get plus 15, I would like to believe. All right. So now everything must be equal to 0. That means this portion must go that side. And if you do that, you're going to get 0 is equals to 5x minus 6y and then plus 15. So therefore, the equation of the line in terms of ax plus by plus c, it is 5x minus 6y plus 15 is equals to 0. So that should be the answer of that particular equation. You can leave your answer just right here. You have answered it nicely in that particular way. So you now have 7 marks in the question. So this is how you go about the first 2 questions. Right, if you have any question, you can always comment to the section below, and I'm going to read your comments just right there. Let's now analyze the diagram just right here. What are they saying to this diagram? They are saying that in the diagram, let me just do this so that I read it with you guys. Let's see. They are saying that in the diagram below this diagram, just right here, the one you're seeing just right in front of me, the triangle AC, the triangle ACR, let me just mark that. The triangle ACR just right here is a triangle with vertices, that means the points. Vertices, it means the points, with the points A, C, and R. But R is not given. A and C are points that are given to us. Now, they further give us something, that is the length of AR. The length of AR is 5 units. So that means from here to here, it's what? It's 5 units. But from here, from the origin to A, it's 2 units. Please get that. This is the Y value. So that is 2 units. It means now the length of OR is going to be what? That means this is going to be 3 units on the premise of the fact that this is 5 units, you know. So 2 plus 3, it's going to give you 5. So that means OR it's 5. I mean, it's 3 units, and the value or the Y value at R is going to be -3 for in case they want it. Now, we go to the next question here, 3.2.1a. They are saying to us, write down the coordinates at R. Okay. The coordinates of R is a very straightforward. Like I was saying, it means there at R, if this distance is 3 units to R, it means this is -3, but x is 0 at that point. It's going to be 0 and -3. All right, so let's write everything properly. So 3.2, I'm just going to write it here, that this is 3.2. And then now you have 3.2.1. They want the coordinates of R. So the coordinates of R, we said is 0 and -3. I hope you are fine with that. So that is the coordinates of R. Now we want to calculate what? The B part of it is to calculate the coordinates of M. Okay, but we were told somewhere here that M is the midpoint of AC. So basically they are looking for the midpoint of AC, which we can do that with our eyes closed. Okay, so I'm just going to go down here and do that with my eyes closed. Remember, this was the A part of this question. So this is the A part of it. Now the B part of it, you want to find the coordinates of M, but you are given the A values, so that is 0 and what? And 2. And the coordinates of C, that is -4 and 0. Just right there. We want to calculate the midpoint of AC, that is M. So M will be x1, you know, that is x1 plus x2 over 2. It's a midpoint formula. y1 plus y2 over 2. Now, this would then mean that M is going to be the midpoint of these two guys, and that is going to be 0 plus -4 divided by 2, and we get the 2 plus 0 divided by 2. Well, let's see what we have. We get M If you really do that carefully, you will see that you're going to arrive to a negative 2 there, and then this one is like 2 over 2, and that is 1 there. So that means the points, the coordinates of M is minus 2 and 1. You can always go and verify in the triangle which you are given. So the point M, it's in the second quadrant where X is negative. So you get a negative 2 and 1. And Y is positive in that quadrant. So you are cool with that. Now we go to the next question. They say to us, the next question, show that RM is perpendicular to AC. So if they say something is perpendicular, you have to now think about the likes of gradient. When you multiply the gradient of RM with AC, it must give you negative 1. Their product must really give you negative 1. That is if they are perpendicular. But if they say to you, prove that RM is parallel to AC, it means their gradient are the same. All right, please get that. They can always throw that question to you in the exam. Now, the next question, let's see that. That is 3.2. So we want to show that RM, we need to prove that. They're saying to us, show that RM is perpendicular to AC. Well, we found the points R to be 0 and what? And negative 3 for the Y value there. And then now we also found the value of M to be negative 2 and 1. So let's find this gradient of RM basically and find the gradient of AC because we do see the points are here. So let me find the gradient of RM and multiply with the gradient of AC. If I get negative 1, that means the lines are, the RM is perpendicular to AC. So therefore, the gradient of RM, that is going to be the change in Y over the change in X, which is like 1 minus 3. So it's 1 plus 3 there, divided by negative 2 minus 0. Clearly, we get 4 divided by negative 2, and the answer is negative 2. Now, we need to find the gradient of AC. So the gradient of AC here, let's see what we get. We do see AC points are here. So it's going to be 0 minus 2. So this is going to be 0 minus 2 divided by, let's see, minus 4 minus 0 for AC. So that is minus 4 minus 0. And as a result, we get negative 2 in the numerator over negative 4 in our denominator. And thus, this gives us a value of half. So now I'm going to multiply that and see if I get negative 1. So now the gradient of RM multiplied by the gradient of AC, let's see, we get negative 2 multiplied by 1 over 2. And as a result, what do we get? We get negative 1. So this concludes to us that RM is perpendicular to AC. All right, this is how you will take the marks in this particular question. You have proven that the product of their gradient is equals to negative 1. Therefore, that is going to be perpendicular to the other line, which is RM and AC. Let's see how you can do the next question. What are they saying here? I see there's 6 marks there. Okay, so I must be prepared for this question. It's 6 marks. So 6 marks questions, they really misbehave at times. They say to you guys, calculate the size. The size, we're talking about the angle, by the way. The size of ACR. So they are looking for the angle C. I don't know why they are writing it in that way. It's AC. There should be a cap there for an angle. I hope they forgot that. So ACR, that means we are looking for that angle. So that means we're going to look at ACR, that triangle, just right there. So I'm going to be doing it nicely there. So look guys, we want to find this particular angle just right here. Let me just mark it properly. We want to find that angle. So this one is a triangle, but I want you guys to see something. We've done something like 2D, in grade 11. So what you can do is you can say, you can get this particular angle if you know the opposite side of that, and that is, we were given it's 5 units. That is AR in this triangle. So that is AR. So AR was given here. So it's 5 units. So this is 5 units as well. That was given to us. Now we need this side as well. So you must know how to find the sides. It's the distance formula as well. Remember that the point at R is 0, and let me delete this portion, is 0 and -3. Well, you can find that length as well. And if you do that, it's going to be 16 squared plus 9 squared, that is 25. So that is root 25, and you get 5 as well. We get 5 units. So I need to get this length as well. I know the sides, the point of that sides. So please, you can try and really look into that side. Let's see if you want to use a distance formula. What are you guys going to get for that particular point? That particular distance, AC. Let's use a distance formula to find AC. So it's going to be 4 squared, and that is 16, plus 2 squared, which is 4, so that is 20. So you're going to get root 20. The distance of AC. Please do that. So I'm going to take that triangle and find that that particular angle. So let's see. And that was 3 point. This was 3.2. This was 3.2.3. We want to find the size of ACR. We have got our triangle. I'm just going to draw my triangle here, and then it's in fact behaving like this. Cool. Let's see. This is C, and then this is A, and this is our R. I'm just taking it outside. And AR, it was what? AR was 5, and this was 5, and this was root 20. And root 20 is the same as 2 root 5, right? So it's the same as 2 root 5. It's root 20. So we want to find this angle. So how do you do that? You can use cosine rule to do that. So I'm going to use cosine rule. And so this is going to be AR squared is equals to CR squared, and then plus AC squared minus 2 CR multiplied by AC multiplied by cos of this portion here, and that is ACR, that angle which you want to find. So now it's a matter of substituting what we have here. AR is like 5 squared is equals to CR. CR is also 5 squared plus AC. So our AC is 2 root 5 and then all squared minus 2 into CR. Our CR is 5 multiplied by AC, which is 2 root 5 multiplied by a cos of ACR, just right here. Now you will see that this will cancel with that. It's 0 basically. So you've got 0 is equals to, and then this one, that is a negative, it's a positive. It's a positive 20, that is 20, I would like to believe, minus, and then this is 10 times 2, that is 20 as well. So this is 20 square root of 5, and then a cos of ACR. Let's see, you can take 20 this side, or take this one that side. Let's just take that one this side. So this is going to be 20 root 5, and then a cos of ACR is equals to 20. What we can do is we can divide throughout by this one. So this is going to be cos of ACR is equals to 20 by 20 is 1 over root 5. So we're going to get this one. So this implies to us that ACR is equals to the arc cos of 1 over square root of 5. Let's see what you guys get in your calculator. Let's see, you get 63,43 degrees. So we get 63,43 degrees. This is how you really go about this question. Yeah, it's worth the 6 marks. You can see that the working was quite tedious. You had to find the distance of all the sides and use the true D arguments. Now, let's see the next question. The next question is this one. They say determine the coordinates of the point S in the third quadrant. That means whatever that you're going to find has to be negative, because in the third quadrant, all points are negative, such that ARS is a parallelogram. ARSC. So there's a point S somehow, somewhere. I want you guys to notice something. These are easy questions. They are giving you ARSC, that is a parallelogram, but this point S, it's in the third quadrant. And if you try to imagine it here, you may not really see ACR as a parallelogram. So the best thing you can do here is to say to yourself, what are you given? Let me go down here and have it just right here. So this is 3.2.4. We are halfway done. So they are saying ARSC is a parallelogram. So this is a parallelogram. Guys, if something's a parallelogram, it means that this one is a diagonal with that one. Those are diagonals of this parallelogram stuff, and the diagonal, they have a midpoint. They meet at the midpoint. Think about it. Let's have a parallelogram like this, and then let me just say that here you are going to have A and S, and then R and C. Yeah. Think about it. A parallelogram, it behaves like this, like the main diagonal, they intersect at the midpoint there. Let's just call it M. So the best approach will be to find the midpoint of one line. In this case, I can't find AS because I'm looking for S. I need to find what? I need to find RC. I need to find the midpoint of RC. Pay attention. I've got R is 0 and -3. They asked me in the first question. And then C was -4 and 0. Let me find the midpoint of this particular line, the diagonal RC. So the midpoint of RC is going to be 0 plus -4 over 2. And then this is going to be -3 plus 0 over 2. And as a result, the midpoint is going to be -2, I would like to believe, and what? And -3 over 2. So this is the midpoint. But this midpoint is also a midpoint of AS. So you can find the point S by what? by the midpoint theorem. Think about it. You have got your A, M, now M is the midpoint, and then you've got your S. Think about it in this way, that the point A was what? The point A was 0 and 2, and then M, you just found it. That is -2 and -3/2. The point S is what you're looking for, so that is XY. But this point must be negative if what we're doing is correct. So I'm going to use the midpoint theorem, which states that the x at M is equals to the x at A plus the x at S divided by 2, and then y at M is equals to y at A plus y at S over 2. Now, what is the y? What is the x at M? That is -2 is equals to the x at A, so that is 0 plus the x at S divided by 2. Now, y at M is -3/2, which is going to be equals to y at A, that is 2, plus y at S, so that is y at S there. So this is y at S. You divide this by 2, and now you can see that you can cross multiply here, or you can still have a -2 is equals to x at S over 2, and then this side, if you cross multiply, or if you multiply throughout by 2, you'd get -3 is equals to 2 plus ys. So therefore, x at S is going to be, you multiply everything by 2, that is going to be -4, and then y at S is going to be -5. This is how you go about it. Now, you say therefore, the coordinate of S is -4 and -5. You can see that they are all negative, but there could have been other methods that your teacher would have shown you, but this is the best approach that one could do, as long as you know what is a parallelogram. This is my analytic view here, and then really straightforward task. Now, what are they saying? Let's see what they are saying just right here. Next to the last question. We're almost done. Calculate the area of a triangle CMR. CMR. Okay, allow me to delete this whole situation just right here. And then I look at CMR now. Okay, I'm gonna have this triangle here, the CMR. So I want to find that area. So this area, this triangle is not a right angled triangle, but we know the angle C. We know what is angle C. So angle C, we found that to be 63,43 degrees. We know what is the size of what of CR. This size was 5 units as well. We just need to find the length of CM. So remember that the point, the coordinate of M was what? That was a -2. I would like to believe that was a -2 and 1. So we can get the distance of CM and find out what is that. Let's find the distance of CM. So CM is going to be the square root of -4 minus 2 squared, so it's more like +2 squared, which is +4, plus 0 minus that, that is going to be 1. 1 squared is like 1. So as a result, we get √5 for the length of CM. So CM, we get √5 by a distance formula. I've just used a distance formula just right here. Okay, it's a very straightforward concept, I would like to believe. Now, we can find the area of that because we now have the opposite sides and the included angle. So the area for this, I can just do it here, maybe just right here, that this is going to be the area of what? Of a triangle CMR. CMR, of a triangle CMR. So how do you do that? You say this is half. Remember, this one is not a right angle triangle, so it's going to be half the opposite sides, which is CM multiplied by CR, they multiply by a sine of that included angle, which is angle C. And then now you just need to substitute your results. So to do that, you're going to get 1 over 2 cm is root 5, and then multiply by CR. CR is 5, multiply by sine of the angle there, and that is 63,43. I'm using a sine rule here. I'm using a sine rule. Sorry. I'm using the area rule. Sorry, students, I'm using the area rule. Just right here. That is the area rule. Sorry about that. The thing, I'm on a 3D. So let's type that. We get 1 over 2 multiplied by root 5 multiplied by 5 there, multiplied by a sine of 63,43 degrees, and then I'm getting 4,999. So in 2 decimal places, let me round it off into 2. Let me retype again so that does it in statistics. So 1 over 2, I'm just trying to type it here. In fact, let me do it with you here computationally. Computationally, where are my calculators here? Should be this one. So we're getting 1 over 2. It's 1 over 2 multiplied by let me just even use these brackets, the square root of 5, the square root of 5 there, and then multiply by you can see here I'm writing 5. Please type it, and then multiply by a sine of 63,43 degrees, and we get 4,99. Here I'm just trying to also verify it with my other calculator, but I hope it's what you guys got. That sine multiplied by sine of 63,43. I close that. That is 4,9978. Yes. And then let me round it off. That is 5. So I'm getting a 5 units. I'm getting a 5 units. I hope students got 5 units. And then if I made any mistake in the calculations of this paper, comment in the section below. I would really love that. But I hope you enjoyed the explanation, guys. Thank you very much for watching, and please don't forget to subscribe to the channel. See you next time.